Hello everyone, our topic today is all about arc length and area of a sector. Let us have a bit from the past. So let us recall how to convert each radian measure to degrees. So remember that pi is equal to 180 degrees. So pi over 3 equals 60 degrees. 7 pi over 4 equals 315 degrees. 11 pi over 6 equals 330 degrees. Pi over 6 equals 30 degrees. 7 pi over 10 equals 126 degrees. Now let's move on to arc length. Arc is part of the circumference of a circle. In general, any 2 points on the circumference of a circle can divide the circumference into 2 arcs. So as you can see in the illustration, we have 2 points, point A and point B, wherein it divides the circumference of the circle into 2 equal parts. We have the major arc and the minor arc. And in the illustration 2, we have the central angle inside the circle. Arc length is the distance along an arc measured in linear units. There is a special relationship exists between the two ratios, okay? So arc length over 2 pi r equals theta over 360 degrees. But today we are going to use another formula to solve for arc length. There's another formula that can be used to solve for the arc length. The picture illustrates the relationship between the radius and the central angle in radians. So the formula S equals R theta represents that S is the arc length and R is the radius and theta is the central angle. Take note that theta must be in radians. So if it is expressed in degrees, we need to convert it into radians. So let us have example for this one. So let us find the arc length. A circle has a radius 18.2 centimeters. Find the length of the arc intercepted by a central angle having each of the following measures. So 3 pi over 8 and B is 144 degrees. So first we are going to solve for the arc length of the central angle which measures 3 pi over 8. To do so, let us have this one. Now let us solve for letter A, wherein theta is equal to 3 pi over 8. So in here, we automatically substitute all the given, the radius and the theta, because our theta is already expressed in radians. So if your angle is expressed in radians already, you will immediately substitute the values. So we have 18.2 times 3 pi over 8 centimeters. And then simplifying further using the calculator, we have 54.6 pi, multiplying the numerator times the numerator, and then denominator 1 times 8, which is equal to 8. So we have 54.6 pi over 8 centimeters. And in the calculator, to simplify this one, just press shift for the pi, okay, shift, and then this tab in your calculator. So 54.6, shift that button, then divided by 8. So that you can have the answer approximately equal to 21.4 centimeters. Now let us proceed to letter B. Convert 144 degrees to radians. In here, since 144 degrees is in degree measure, we are going to convert it to radians using the formula 144 times pi over 180. So in doing this, we have 4 pi over 5 radians. Then we are going to substitute it in our formula. S is equal to r theta. So we have 18.2, which is the radius, times 4 pi over 5 centimeters. And using the calculator, we have 72.8 pi over 5. Then encode 72.8 and then shift the button that I told you divided by 5. It is approximately equal to 45.7 centimeters. Now let us have another one. A rope is being wound around a drum with radius 0.8725 feet. How much rope will be wound around the drum if the drum is rotated through an angle of 39.72 degrees? So in here, since our central angle is in degree measure, we are going to convert it into radian. So from here, substituting the values, when we substitute it, so 0.8725 times, to convert 39.72 degrees to radian, we are going to multiply it by pi over 180. So we have 0.8725 times 39.72 times pi over 180 degrees. It is approximately equal to 0.6049 feet. Now let us have another one. Finding an angle measure using S is equal to r theta. So two gears are adjusted so that the smaller gear drives the larger one. If the smaller gear rotates through an angle of 225 degrees, through how many degrees will the larger gear rotate? So in here, we are going to find first the radian measure of the angle and then find the arc length on the smaller gear that determines the motion of the larger gear. In order to do so, the first step is to convert 225 degrees to radians. So 225 degrees equals 5 pi over 4 radians. So after converting our theta to radians, now we are going to solve for the arc length on the smaller gear. In order to do so, we are going to substitute the radius, which is equal to 2.5, and our theta, which is equal to 5 pi over 4. Simplifying further, we have 12.5 pi over 4, and using your calculator, 12.5 pi over 4 equals 25 pi over 8 centimeters. And from here, we are going to determine the angle measure for the larger gear, okay? Using the formula S is equal to r theta, we are going to substitute the arc length of the smaller gear as well as the radius of the larger gear. So we have 25 pi over 8 equals 4.8 theta. Dividing both sides by 4.8, in your calculator, we have 125 pi over 192. And from here, we are going to convert our theta to degrees. In converting it, we are going to multiply it by 180 degrees over pi so that we can cancel. So using the calculator, it is approximately equal to 117 degrees. So the larger gear rotates through an angle of 117 degrees. Now let's move on to the area of a sector of a circle. A sector of a circle is a portion of the interior of a circle intersected by a central angle. So think of it as a piece of pie. So as you can see, it's like a pie, okay? A piece of pie. The shaded region is a sector of the circle. So the area A of a sector of a circle of radius r and central angle theta is given by A stands for the area equals 1/2 r squared theta, where theta must be expressed in radians. So let us have some examples. First, finding the area of a sector-shaped field. So let us find the area of the sector-shaped field shown in the figure. So in doing this, we have to use the formula area is equal to 1/2 r squared theta. And then we are just going to substitute the values. But since our theta is expressed in degrees, we are going to convert it to radians. Okay? And to convert it, we are going to multiply it by pi over 180. So from here, we are going to have 1/2 times 321 squared times 15 times pi over 180 degrees. And using the calculator, it is approximately equal to 13,500 square meters. So let us have another one, area of a fairway. And what is a fairway? A fairway is the part of a golf course between a tee and the corresponding green where the grass is kept short. So if you went to a golf course already, you know what I am telling you. So going back to the problem, a sprinkle on a golf course fairway is set to spray water over a distance of 70 feet and rotates through an angle of 120 degrees. Find the area of the fairway watered by the sprinkle. So the first thing that we should do is to convert 120 degrees to radians. And 120 degrees equals 2 pi over 3 radians. And the next step that we are going to do is to substitute all the values in our formula, which is equal to the area equals 1/2 r squared theta. So since we have already our angle expressed in radians, we can substitute it already. So simplifying further, we have 4,900 pi over 3, and using the calculator, it is approximately equal to 5,131 square feet. So let us have the last example for today. It is a combination of your arc length and area of a sector. Find the arc length S and area A of the sector of a circle of radius 7 centimeters and sector angle 2 radians. So in here, we don't have to convert anymore our angle into radians because it is already expressed in radians. So the first thing we need to do here is to solve for the arc length using the formula S equals theta times your radius. Substituting all the values, so we will be having 7 times 2. So S equals 14 centimeters. So the arc length equals 14 centimeters. Now let us compute for the area of the sector of a circle. So in here, we are going to use the formula area equals 1/2 radius squared theta. And substituting all the values, so radius equals 7 centimeters and theta equals 2 radians. So we will be getting 1/2 times 7 squared times 2 using the calculator, or you can just cancel and cancel 2 over there. So the area of the sector of the given circle equals 49 square centimeters. So that's it for now. Thank you very much for watching. Please do subscribe to my channel. See you again next time. Bye!